Hello guys, redox reaction, reduction and oxidation reaction. So we want to balance half reaction. Are we together? So now I have few questions here written down here. So the first one is Zn plus Ag plus to give us what? Zn2 plus what? Plus Ag. Now we check the charge of zinc here is 0. Here is 2 plus. That means zinc increase, right? Increase in oxidation number. That's oxidation. If you check silver here, Ag, argentium, and here is reduced. So silver undergo reduction, while zinc undergo what? Oxidation. So zinc oxidation is loss of electron. To make it Zn2 plus, it has to lose two more electron. Are we together? It has to lose two more electron to give us what? Zn2 plus. So here we can turn it to Zn to now give us what? Zn2 plus. If this one comes to the other side, it become plus 2A minus. So whenever you have plus electron on the other side, why are we making this electron 2? Because the charge is true. Whenever you have plus electron on the right side, it's loss of electron because initially it was on the left by subtraction. But whenever you have this plus on the left, is gain. If you have it on the right, it's loss, which is oxidation. If you have it on the left, it's gain, which is reduction. So now let's write the half reaction for silver. So here we have Ag plus. Because Ag is reduced here from this to this, that is gain of electron. Gain of electron, E minus to give us what? Ag. Whenever there is a reduction is in oxidation number, like that's reduction. Reduction is gain of electron, so it's going to gain E minus. So you can see this. We have the electron on the left side here, that's gain. We have it on the right side here, that's loss. So how can we balance these two half reaction? Is by multiplying equation 1 by 1. If you multiply this by 1, you use the coefficient of the electron. The coefficient of the electron here is 2, here is 1. So use the coefficient of electron here to multiply the first equation and use the coefficient of electron here to multiply the second equation. If we multiply this by 1, we still get the same thing. Now this times 2, we are going to get 2Ag plus 2A minus to give us what? 2Ag, right? So you can see that these two plus can now cancel these two plus. Yes, it can. If you bind the two equations together, if you gather this and this together, it's not necessary this. If it is minus here itself, it cannot cancel. Yeah. If we gather these two equations together and we take this one to the other side to come and meet this one, it will turn to minus. So it will just cancel. So now since it has been cancelled, let's write what we have left. Here we have Zn on this side. What do we have on this side? Plus 2Ag plus to give us, what do we have on this side? Zn2 plus what? What do we have on this side? 2Ag. On this side we have what? 2Ag. After you've balanced it like that, after you've written your half reaction and you check the number of electrons, if they are not equal, you balance the electron out. Forget about the coefficient of all this. You are checking the coefficient of electron. Since this has 2 electrons, multiply equation 2 by 2. Since this have 1 electron, multiply equation 1 by 1. So it's going to give you, this will remain this because I'm multiplying by 1. This one will turn to this because I'm multiplying by 2. Then the electron will now be balanced. It will cancel out. Then what you have left is Zn on this side. What do you have on this side? 2Ag plus. What do you have on this side? Zn2 plus. What do you have on this side? 2Ag plus. Do you have there? Now you can see that the two equations now they are not balanced. So let's check if they are truly balanced. How many charges do we have here? This plus 1 times 2, 2 plus. How many do we have here? This also 2 plus. So the equation they are balanced. We have 2 silver, we have 2 silver, we have 1 zinc, we have 1 zinc. The number of atoms are balanced. The number of charges are also balanced. Now let's move to the second question. Now, in the second question, we have Mg plus Fe3 plus to give us Mg2 plus what? Fe. Now, looking at this equation, for us to write the half reaction, let's first check which one undergo oxidation, which one undergo reduction. You can see the charges on iron on the left side, 3 plus. On the right side, it's just 0, which means iron is reduced. That's reduction, right? So you can see the charge on magnesium on the left side, that's 0. The charge on magnesium on the right side, that's 2 plus. So you can see that here magnesium is increased, which is oxidation. So magnesium undergo oxidation. How do you write the half reaction for oxidation? I told you whenever you have electron on the right side in addition format, that's loss of electron. Oxidation is loss of electron, reduction is gain of electron. So in the half reaction, loss of electron is when you have plus electron on the right. It was initially minus electron on the left. Or you can take it this way. When you have minus electron on the left, that's oxidation, loss of electron. When you have plus electron on the left, that's reduction, gain of electron. But that since you can't leave subtraction of electron like in a half reaction, it has to be plus plus. So you have to bring the one from the left to the right. So you say magnesium lose 2 electrons to give us what? Mg2 plus, right? So this half reaction turns to Mg equals to what? Mg2 plus what? 2e minus. This is loss of electron now because that plus E minus is on the right side. But assuming this plus is on the left side, that's gain of electron. Now for reduction is always gain of electron. Don't forget about that. While oxidation is loss of electron. Now for iron, for ferrium, we have Fe 3 plus is going to gain 3 electron to give us what? Fe. Are we together? Let's say this is our equation 1 now, and this is our what? Equation 2. So now, you can see that the number of electron here is 3, the number of electron here is 2. So how do we balance the two equations? Is by multiplying this one by 2 and multiplying this one by 3. We want to balance electron, that's the main idea. Then at the end of the day, everything will definitely be balanced. Now, Mg times 3, here we have what? 3 Mg to give us what? Mg2 plus times 3, we have 3 Mg2 plus. Then this times 3, we have what? 6 E minus, isn't it? Fe times 2, we have what? 2 Fe 3 plus. Plus this times 2, we have 6 E minus to give us what? Fe times 2, we have what? 2 Fe. So you can see now this electron now 6 E minus 6 E minus can what? Can cancel out. So that's one of the idea to cancel out the electron. Now that we've cancelled out, now what is left here is 3 Mg. What do we have left here? Plus 2 Fe3 plus to give us, what do we have left here? 3 Mg2 plus. What do we have left here? Plus what? 2 Fe plus 2 Fe. So now let's check. Now here is the charge is balanced. The charge we have here, on this one we have 0 charge. Here we have 3 plus times 2, that's 6 charges. Here we have 2 plus times 3, that's also 6. Here we have 0. So 6 plus 0, we have 6 in total. 6 plus 0, we have 6 in total. So the charges are balanced. Now let's check the atom. Here we have 3 magnesium. Here we have 3 magnesium. This charge, this is not number of atom. 3 magnesium is balanced. We have 2 iron, we have 2 iron. So it's balanced. So that's that for that. Now before we move to the acidic medium, now let's check the last one under this basic analogy. Now let's try well, let's move to acidic medium. That's so that we won't waste much of our time. Okay, now let's just solve that. So now the next one we have Al plus Cu2 plus to give us Al3 plus Cu, aluminium and copper. Now we can see that the charge on aluminium here is 0. Here the charge is 3 plus, so that is oxidation. Here is 2 plus, here is 0, that's reduction. So that means aluminium undergo oxidation. And what's oxidation? That's loss of electron. Don't forget, maybe you should use this code. Okay, leave that one. Yeah, leave that one. So oxidation is loss. Yeah, use this one. Oxidation is loss, reduction is gain. Oil rig, oil rig. You can use this code. Oxidation is loss of electron, reduction is gain of electron. Don't forget that. So now aluminum is oxidized from 0 to 3 plus. So oxidation is loss of electron, and because it becomes 3 plus, that means we are going to subtract 3 electrons, right, to give us what? Al3 plus, isn't it? Why is this thing fade like this? So here now we have Al to give us what? Al3 plus. If this comes to the other side, we have what? Plus 3E minus, isn't it? So at the end of the day, This is our first equation. Now the second equation now, copper is reduced. That's gain of electron. Cu2 plus what? 2e minus to give us what? To give us Cu. This one gained 2 electron, this one lost 3 electron. That's equation 2. Now how do we balance the electron now? How do we balance the electron? It's by the coefficient of electron here is 3, the coefficient here is 2. So multiply this one by 2, multiply this guy by 3. 2 times Al, we have 2Al. To give us 2 times this, we have 2Al3 plus 2 multiplied by this, we have 6E minus. 3 times copper, we have 3Cu2 plus. 3 times this, we have 6E minus. To give us 3 times Cu, we have 3Cu. So 6E minus cancel 6E minus. Now let's write the final equation. So on this left side, we have 2Al and 3Cu2 plus. So here we have 2 2Al plus what? 3Cu2 plus, isn't it? To give us, on the right side, we have 2Al3 plus 2Al3 plus what? Plus 3Cu. If you count the number of charges, they are balanced. If you count the number of atoms, they are also balanced. Now, without wasting much of our time, let's move to acidic condition. So, balancing reaction, half reaction using acidic medium, AC. Now, one thing you need to know, in both acidic medium and basic medium, we can add water. But in acidic medium, we can add um, hydrogen ion as well. But in basic medium, you can only add hydroxide ion. You can add water in both. But for acidic, you can add hydrogen ion as well. In basic, you can add hydroxide ion, not hydrogen. Now, the first question we'll be dealing with here are bromine and zinc. When we have BrO3 minus plus Zn to give us what? Br minus 1 plus what? Zn2 plus. Now, one thing you need to know quick is that regardless of the number, regardless of the charge on this bromine, regardless of the charge, regardless of what is on it, since this guy contains two elements and this is just one element, so it is always reduction. Take note of that. From two or from more than one element to a single element, it is reduction. Are we together? And like removal of what's it called? Removal of oxygen. Removal of oxygen, that's reduction. So oxygen was here before, oxygen is no longer here. So automatically this bromine here, bromine oxide here undergo reduction to give us bromine alone. Now, and this should be the oxidation. So here we have Zn from 0 to 2 plus. Zn oxidize to give Zn2 plus what? 2e minus. Now this plus 2e minus was initially minus 2e minus on the left side. So, but because we can't leave that subtraction on the left side, we have to bring it to the right side. So we have to bring it to the right side. So let's say this equation 1. Now we also have BrO3 minus to give us Br minus 1. Now in this case of acidic medium, don't balance the electron first. First balance the atom. You can see that there is oxygen here, we don't have oxygen here. So now how many oxygen do we have here? 3. Then add 3 molecules of water to the right side. 3H2O. If you have 5 here, you have 5 molecules of water. That's how it's been done. But we also have exception. It depends. There are some cases that we may only add one H2O. It depends on what we have on ground. But as far as all these are concerned, this base case, we still get to question that probably we may not have the number of oxygen in terms of water molecule. So we have 3 oxygen, had 3 molecules of water. Now the right side now, oxygen is still here, oxygen is still here, balance. But let's see, how many hydrogen do we have here now? 6. So you have to balance this side too. How do we balance it? Add what? 6 hydrogen ion. So now we have balanced the atom. Now it's left for us to balance what? The charges. Are we together? So how many charge do we have on the right side? Just minus 1. Minus 1. How many charge do we have on the left side? That's 6 plus 6. So how do we make them to be equal? How do we make them to be equal? So you what you do is that side with H plus, is what you will make to be equal to this one. Do you get what I'm saying? Like this you are adding the charges to be balanced to that side with H plus, not this side. So you are trying to make this to be equal to this. So what to make what to make 6 plus to be equals to minus 1? That's by adding what? Let's say 6 I'm coming minus 1 equals to 7. Yeah, 6 minus 1 equals to 7 is subtraction actually. So on this side you are adding 6 electron. I'm using left hand there. 6, sorry, I'm using left hand there. 6 E minus. Yeah, see the side with H plus, you that's the side you are, you may feel like since this is 6 plus, then let's make this one 6 plus. Then you add whatever. Do we get? Since electron is negative, okay, it's not even that condition. It's not even that condition of the side with H plus. No, no, no. It's not even that condition. Yeah. Because if you should add 6E minus here or whatever, there is no if you should add electron here, there is no day, there is no life, there is no year. How many years that you can make this guy to be equal to 6 plus? No, this is negative. If you add 1, this one will become minus 2. If you add 2, this will become minus 3. If you add 3, this will become minus 4. There is nothing you want to add. Since the charge on electron is negative, this place can never be positive. So we can never make these two to be balanced no matter what we do. So that's why the electron is must be added to this side. So it's not maybe about, so just take it that way, that last expression. Though the first thing I said is not bad. So add the 6E plus here, 6C minus rather, plus 6C minus. Now here we have, it should be 7, sorry. It should be 7. Yeah. 6 minus 1. Assuming we have minus 2 here, to be 6 minus 2, then that will be 8. So it should be 7. You can just do your mathematics there, there's no problem. So here we have 7 minus 7, right? And plus 6. Minus 7 plus 6. So here will be minus 1. Here we also have minus 1. So what happened that way? The electrons are also what? Balanced, isn't it? Now what are we going to do? Here we have 7E minus. Here we have 2E minus. How do we balance it? Multiply this by 7. Multiply this by what? By 2. 7 times Zn, we have what? 7Zn. To give us 7 times this, we have 7Zn2 plus. Plus 7 times this, we have 14E minus. 2 times 7E minus, we have 14E minus. 2 times this plus 12H plus to give us 2 times Br. This we have, sorry, this plus what? 2BrO3 minus to give us 2 times this, we have 2Br minus 1. 2 times this, we have what? Plus what? 6H2O. Now you can see that this one now, where's that zinc? This is that for the zinc. This is this for this second one. Now this 14E minus, we cancel this 14E minus, isn't it? Let me clean the upper part so that we can see what we are doing very well. Now what do we have on the left side here? We have 7Zn. What do we have on the left side here? We have 12H plus. What do we have here? Plus what? 2BrO3 minus to give us, what do we have on this left side here? Z 7Zn2 plus. What do we have here? 2Br minus 1 plus 6H2O. Now let's check that. Now let's check if everything is balanced. Here we have 7 zinc, 7 zinc. Let's check the atom first. Here we have 12 hydrogen. We have 12 hydrogen balance. Here we have 2 bromine, 2 bromine. Here we have 6 oxygen. 6 times 3. 2 times 3 rather, 6 oxygen. Well, here we also have 6 oxygen. So the atoms are balanced. Now let's check the charge. Here we have plus 1 times 12. We have 12 charge here. Here we have minus 1 times this, minus 1 times 2. Here we have 12 minus 2. So the total, this plus 12 minus 2. The total, this one is 0. So the total charge on the left side is plus 10. Now let's check the right side. Here we have 2. Here we have 2 times 7. That's 14. So here we have minus 2. Okay, the charges are not balanced. Now let's check. There's a mix up somewhere. Ah, I can't really figure where the mistake. Here we have 10. Here we have 12. It's not balanced. It has to be. I can't figure it. Maybe the question. Well, I don't want to waste much time on that. So let's do the next one. We do that one very well. But take note that charge is not balanced. So that's reaction. It's not yet balanced. That one is not yet balanced. But I don't want to waste time on that. Let's just move to the next question. So we deal with it very well in the next question. Plus ClO minus to give us what? ClO minus to give us Al3 plus what? Cl minus. Now let's do this guy very well. Let's calm so that will not make mistake. Sorry for the previous one, but at least you learned something from that. So which you are going to apply here as well. Now aluminium here increase in charge, so that's oxidation. So Al to give us Al3 plus what? 3E minus, right? Now for ClO minus plus, okay, to give us what? Cl minus. This one don't add electron yet. First balance the atom. No, this place now the atom is balanced. That's why we are moving to the electron aspect already. But when you see that the atoms are not balanced, first balance the atom before adding electron. Now here we have oxygen. There's no oxygen. How many oxygen do we have here? One molecule. One oxygen, right? One oxygen rather. So yeah, add one molecule of water. Just add H2 to this side. So oxygen is chlorine is one, oxygen is one. But here we have two hydrogen. So plus add 2H plus to this side. Do we get that? So now hydrogen is balanced, oxygen is balanced, chlorine is also balanced. Now let's not balance the electron now. So how many electrons do we have here? Here we have 2 plus minus 1. That, 2 minus 2 plus minus 1, that's 1 plus 1. Here we have minus 1. If you continue adding electron to this side, there is no how it can turn to positive because electron itself is negative. This side will become more negative. So we only have to add electron to this side. So how many electron do we need to add to plus 1 that will make it minus 1? It is 2 electron, right? So let's say 2e minus plus. So if you add 2e minus to plus 1, it will become minus 1. So the charges are now what? Balanced. So now, but the next thing here now, how many electrons do we have here? 3. Here we have what? 2. Our E here is 2. Here is 3. So multiply this one by 3. Multiply this by what? By 2. So now 2 times Al, we have 2Al. To give us 2 times this, we have 2Al3 plus. 2 times this, we have what? 6E minus. 3 times this, we have what? 6E minus plus. 3 times this, we have 6H plus. 3 times this, we have 3ClO minus. To give us what? 3 times this, we have 3Cl minus. 3 times this plus 3H2 what? H2O. So this 6C minus can cancel this 6C minus. So what do we have left on this left side? We have 2Al. What do you have left here? Plus 6H plus 3ClO minus to give us, what do you have on this side? Cl minus. What do you have here? Oh, sorry. What do you have on this side? 2Al and this, right? Now what do we have on, yeah, this? We have Al3 plus 2Al3 plus. This is the one we have cancelled. This the one we have on the left here is this. On the left here is this. The one we have on the right here is 2Al3 plus 2Al3 plus. The one we have on the right here is what? 3Cl minus plus what? 3H2O. Now let's check if they are balanced. Now we have two. Let's check the atom before the charges. We have two aluminum. Two aluminum is balanced. We have 6 hydrogen. 3 times 2 here. We have 6 hydrogen as well. Is balanced. We have 3 oxygen. So here also 3O. So here we have 3 times 1. We have 3 oxygen balanced. We have 3 chlorine. We have 3 chlorine. So all the atoms are balanced. Now let's check the charge. Now for the charges here, Here we have 6 times plus 1. Here we have plus 6. 3 times minus 1. We have minus 3. So here we have plus 3 in total. We have plus 3 in total there. But for the right side, 2 times 3, we have plus 6. 3 times minus 1, we have minus 3. We also have what? Plus 3 in total. So both charges and the atoms are balanced. So this is our balanced reaction, balanced equation. So that's how to do it in acidic medium. You add molecules of water, then you check. If I had water here, what happened to the other side? The other side is lacking hydrogen. Then add hydrogen atom there. Hydrogen ion. So that's it. But for basic medium, when you add water, whatever the other side is lacking, you add hydroxide ion, not hydrogen. Now let's do one more under acidic medium before we move to basic medium. Now manganate and iron. This is a single element. This is two elements. So it's reduction already. So this one is oxidation. So here we have Fe oxidized to give us Fe3 plus, right? So that's loss of electron. That's minus 3 minus. But let's take it to the other side to become what? Plus 3 minus. So for MnO4, for manganate, don't add electron yet. First balance the atom. You see, this one has oxygen, this one does not have. So balance the atom. We have Mn2 plus. So how many molecules of oxygen do we have here? 4. So how many atom rather? We have 4 atoms of oxygen because it's just a single element. Do we get? So we have 4 atoms of oxygen. So that means we are going to add what? 4 molecules of water. So we have 4 what? H2O. So oxygen is now balanced. Now let's check hydrogen. Here we already have 8 hydrogen. That means we are going to add what? 8 H plus to the other side, right? Now the atoms are now what? Balanced. Now let's check the charges. How many charge do we have here? We have 8 plus, and you are not using this to multiply. It's only the coefficient of the whole molecules that are used. This one is just, so this is just minus 1 here. So here we have 8 minus 1. So here becomes 7. How many do we have here? 2 plus. Plus 7 and 2 plus. So what are we going to, how can we make plus 7 to become 2 plus? There is no how you can make this 2 plus to become plus 7 because it will keep on reducing till it gets to negative. But this one can reduce and get to 2 plus. So that means, sorry, that means we are adding electron to this side. So how many electron are we adding? Here we are, that should be 7 minus minus 2, that's 9. So we're adding 9 electron to this side. That's 9 E minus plus. We're adding 9 electron. Just do your math. Do your math there. So because this 9 E minus plus what? So here now we have minus 9 plus 8 minus 1. It becomes what? And come, let me check. No. 9. This one is plus 2. Sorry. It's not minus 2. We are not adding minus 9. What we are adding there? Assuming this is minus, that's when we will be doing 7 minus minus 2. But it's 2 plus, so it will be what? 7, just 7 minus 2. Assuming it's minus, it will be 7 minus minus 2, like the one we have been doing. You can just do your math there. It's not hard. How can you turn 7 to 2 to plus 2? Assuming, how can we turn 7 to minus 2? Yeah, that's by adding plus 9. But how can we turn 7 to plus 2? Just add what? Plus 5. Do we get? So this one should be 5. So that should be 5. So now we can see that the coefficient of electron here is 5. The coefficient here is 3. So how do we balance it? Times 5 times what? Times 3. 5 times Fe, we have 5 Fe. To give us 5 times this, we have 5 Fe3 plus. Plus 5 times this, we have 15 E minus. 3 times this, we have 15 E minus. 3 times 8 plus 24 H plus. 3 times this, we have 3 MnO4 minus. To give us 3 times this, we have 3 Mn2 plus. Plus what? 3 times 4H2, we have 8 H2 H2O. So 15E minus, we cancel 15E minus, isn't it? So now what do we have on the left side? What is left there? We have 5Fe. What is left here? Plus 24H plus what? 3 MnO4 minus to give us, what do you have left here? 5Fe2 plus. What do you have left on this right side? On the left side and on the left side here, you gather them together. The right side and the right side here, you gather them together. Here we have the right side here is this. The right side here is 3Mn2 plus what? 8H2O. 8H2O. Now let's check the atom and the charges if they are balanced. Now we have 5Fe, 5Fe is balanced. 24 hydrogen. Wait. Hydrogen is not balanced. It's balanced. I made a mistake. 3 times 4 is 12. I wrote 8. 3 times 4 is 12. Thank God like that. So it's balanced. So we have 5Fe on the right side, balanced 24 hydrogen. So this is 12. 12 times 2, 24, 24 hydrogen. 3 manganese, 3 manganese, 3 times 4, 12 oxygen, 12 oxygen, 12 oxygen as well. 12 is the coefficient here, 12 oxygen. Can we see that? Now for the charges, at the charges balance, here we have 24 times plus 1. We have 23 times minus 1, that's minus 3. So here we have 24 minus 3. We have 21 charges plus 21 charges on the left side. Now let's check the right side. Is it up to or more than 21 charges? 5 times 2 plus, we have 10. 3 times 2 plus, we have 6. That's 16. We have to check. Something is not balanced here. So what's happening? Here we have 21, here we have 16. What's happening? What's happening? Okay, sorry. This is 3 plus. Fe3 plus. This is it. Not 2 plus. Please just be very careful in case you are doing your exam. Don't mix things together. The left side there is 5E, 5E. The left side there is 24, 24. This. The right side there is Fe3 plus. Fe3 plus. The right side there is this, and H2O, this. So this is Fe3 plus. 5 times 3, that's 15. 3 times 2, that's 6. 15 plus 6 is 21. So the two charges are balanced. So thank God for that. Maybe that's one of the mistakes we made in the first question. So please, that's how to. Now let's move to basic medium. Don't forget to like and subscribe. If you have any question, just drop it on the comment section. I'm going to answer it. Now for the basic medium, let's say we have Fe plus ClO minus to give us FeOH2 plus what? Cl minus. So that's the question. So that's the question now. Now Cl is reduced obviously. The oxygen is not here, so it's reduced obviously. And this one is oxidized. So now we have ClO minus to give us Cl. So in this case, reduction, we should have added the electron already, but I told you first balance the atom in cases like this. So how do we balance the atom? We have one oxygen here, right? So what happened here? So here let's add one H2O. I'm coming. Okay, let's add one H2O. Fine. So oxygen is balanced, right? Now out of hydrogen here we have, I told you basic medium. You are not adding hydrogen ion. What you are adding is what? Hydroxide ion. So here let's add 2OH minus. 2OH minus. So yeah, now let's see what is happening here. Here we have hydrogen is now this is now 3. Oh yeah, sorry. In basic medium, yeah. Sorry about that. In basic medium, always add the water to the side that have more hydrogen. Yeah. Sorry about that. In acidic medium, we add the water molecule to the side with less hydrogen. But in basic medium, add water to the side with more hydrogen. Add water to the side with more hydrogen. So we are adding the water here, H2O. So here now, oxygen is now 2, hydrogen is also 2. So this one becomes what? Add 2 hydroxide ion. Oxygen is balanced now, hydrogen is also balanced, 2 and 2. 2 and 2. For acidic medium, you can add water and hydrogen ion. Add water to the side with less hydrogen, then hydrogen ion to the other side because it's going to lack hydrogen after adding water to the side with less hydrogen. But for basic medium, you can only add water and hydroxide ion. For basic medium, add water to the side with more oxygen rather. Initially, I mentioned hydrogen, I mean oxygen. Let me repeat again. In acidic medium, add water to the side with less oxygen. Then you are going to add H plus to the other side if it's lacking H plus. In basic medium, add water to the side with more oxygen. Then on the other side, you are going to add OH minus. So the number of OH minus will be determined by the amount of O and H that you have on this side. So here now we can see that it's already balanced. This is the only one question I will solve on basic medium, but I will explain it very well. Or I may solve two and give some assignment on it. Now let's see what happens next. Now, let's write for Fe. Fe to give us what? Fe OH OH2. Now here we can see that here we have 2OH. This one. So obviously, what are you going to do? Add hydroxide ion to this side. 2 molecules of hydroxide ion. Now O is 2,2, H is also 2,2. Everything is balanced. Everything is balanced. So what's the next thing now? Let's now how to know where to add and the amount of electron to add. Now let's check since all the atoms are now balanced. Now let's check all the charges if they are balanced or not. If all the charges are balanced, then we can just add the two equations together, and then that will be the final answer. But if they are not balanced, we are going to either add electron to whatever. Now for this one, here we have how many charge do we have here? We have -1. On this side we have -3, right? This 2 minus and 1 minus, that's -3. So how do we make them to be equal? Now if we keep adding electron here to this side, it will keep increasing in negative. From -3, if you add 1 electron, you have -4. If you add 2 electrons, you have -5. So it can never be -1. So for -1 to be -3, the electron has to be added here. So if we add 2 electrons here, so this place becomes 2e minus, do we get? So -2 and -1 is now -3 is balanced. Now let's check the other one. Here the charge here is 0. There's no charge here. The charge here is -2. How do we make both of them to be 0? So now if we add, now which side are you going to add? This side or this side? It's this side actually, because there is no how this can be reduced to 0. If you keep on adding electron, it will become more big in the negative, like it become having negative. It can't be reduced to 0. But here is by adding what? 2e minus. So do we get what you are saying now? So what's the next thing to do now? So I think since the electron we added to both is 2e minus 2e minus, that means in the first place the equation is balanced. Do we get? Well, we don't know yet. Always try it by confirming. It's not about, if we add this left to this left and add this right to this right, it may be balanced. But first check the electron first, probably, or you can check either way. So this one we cancel back. That means we don't even need them in the first place. So you can first check and add this time. Assuming we are adding 3 here now, then we have to multiply by 3, multiply by 2. But since it's 2, 2 is balanced. That means in the first place, even before we had this, they are balanced. Let's check if they are indeed balanced. Now, what are the left side there? We have H2O plus what? ClO minus to give us, what are the right side there? We have Cl minus plus, sorry. The left side there is what? H2O plus ClO minus. The left side there is what? 2OH minus plus what? Fe. To give us the right side there is what? Cl minus plus what? 2OH minus plus what? Fe OH what? 2. Write all the left side and the right side together. Now let's check. If it's not balanced, now that means there is a mistake. But since this guy are equal, by balancing the two sides and the two sides, since this one are equal and they can stick, that means initially without checking, they are also balanced. Now we have how many hydrogen do we have here? Let's first check the molecule. Here we have two hydrogen plus another two, that's four. Here we have two hydrogen plus another two, that's four. Let's check oxygen. We have one oxygen, that's two plus two, that's four. Here we have two oxygen, that's also four. Let's check chlorine. One chlorine, that's balanced. Let's check iron. One iron, that's balanced. Now all the atoms are balanced. Now let's check the charge. Here we have minus one and minus two. Two minus two times minus one, that's minus three, right? Here we have minus one, minus two, that's minus three. So it's balanced already. So now let's do one more question. Then I will give you the rest as assignments. So now here we have I minus plus ClO3 minus 1 to give us I3 minus 1 plus Cl minus minus. There's no need of putting one. So um now for this one is reduced because there's a loss of oxygen, ClO3 minus, to give us what? Cl minus. But we have to balance the atom first. Now this is a basic medium, not acidic medium. So you are adding water to the side with more oxygen. If it's acidic medium, you're adding water to the side with less oxygen. Do you get? So this guy is going to become plus what? 3 molecules of water. Do we get? Now to how many oxygen do we have on this side now? We have three and three, that's six, right? How many hydrogen? We also have six. So on this side, you are going to add what? 6 OH minus. It's balanced now. Don't make mistake. In acidic medium, you're adding water molecule to the side with less oxygen. In basic medium, you're adding water molecule to the side with more oxygen. We have few exceptions in basic medium at times. That it depends on the kind of what gives you this. It depends at times. We have some exception, but just know it that way. When we get to those exception side, you also understand the way I'm going to explain it. Now we are done with the first one. Now for iodine, the atom are balanced already. Here we are not talking of number. We are not talking of whether this is one, this is three, but it's hydrogen, hydrogen. There's no additional whether it's this one has oxygen, this one does not have. There's no problem about that. Now, okay, I think we are going to add 2I here to make this up to 3. We are going to know along the way, there's no problem. To make this up to 3, I think we are going to add 2I. Now, yeah, we balance the atom too. Yeah, we balance the atom. Yes. Add 2I here. So we have 3 iodine and 3 iodine. Fine, no problem. So now, let's check the charges. Now, the charges here is -1, right? And this side is -1 and -6. That's -7. How do we make -7 here to be equals to -1? It's by adding 6 electron here. 6E minus plus. So here is already -7 and -7. They are balanced. Now, always balance the atom. Please take note of that. So I have to add 2 iodine here to make it up to 3. Now here we have charges -1, -1. The charges are balanced, isn't it? So we don't need to stress. We don't need to stress ourselves with this one. So, but now, how do we now balance the electron? How do we balance the electron? So this is going to be what? Times 1. This is going to be what? You are going to multiply this one by 6, the number of electrons. Wait. I think, mm, wait. Electron has to be on this side. Well, something I'm trying to get what we are going to do here, and I don't want to waste our time by making the video so long. Um, okay, let's pause on this. It will be part of the assignment. I'll just confirm. I will confirm and I will drop the solution. So let's not waste time on this. I need to check something on that. So let me just do one more. I want to make sure that we do one more. So let's have one more. SO3 2 minus plus NiOH 3 minus to give us Ni plus what? SO4 2 minus. I hope I'm writing all this. I hope all these equations are correct. But please, what we have explained so far, they are 100%. Just know those one and be able to apply them. Okay, let's check this question as well. Let's check. Let's check. So now what is going to happen here? This one is reduced because there is loss of oxygen, so it's reduced. This one is increased. This is sulfur 4. This is sulfur 6. This is sulfate 6. This is sulfate 4. So this one is increased. This one increased from 4 to 6. Like this tetraoxosulfate 4, this tetraoxosulfate 6. So this one increased from 4 to 6. That's oxidation. So we are not even balancing the charges yet. So I don't even need that for now. So now, like I said, you are going to add water to the side with more oxygen for basic medium. So plus what? H2O. Now should we add 4H2O? Now I told you the number of oxygen will be the number of water you will add. Now, but because we already have 3 oxygen here, I think we can just add one more water. Let's check. Assuming we add one more water, let's see. It's something that you can just use your. Now, let's add OH here. OH minus. OH minus. Now, let's check the number of oxygen. 4. Oxygen here is now 5. If we had 2 OH minus here, oxygen here is 5. Oxygen is balanced. So, yeah, it's balanced that way. So why do we not need to, like I said, we have some exception such a way that it's not every time you be saying since the number of hydrogen oxygen is 4, then add 4 molecules of water. You don't need to add 4 molecules of water. The reason for adding molecules of water is to first of all balance the number of oxygen. Since you already have 3 oxygen on this side, I think for this case you can just add 1 molecules of water. So number of oxygen. Do we grab that? And just um assuming it's acidic medium now, you will understand this very, very well. You understand it very well. Assuming it's acidic medium. Because here now it's like we are even increasing oxygen here. And this is just 3. This has become 5. Now it is easy to make this balance now. 5 and we still have 2 hydrogen, 2 hydrogen. So even though if you want to say 4, there's no problem, you still get your answer. Put 4 here. Here now we now have what? 8 oxygen, right? And 8 hydrogen, right? How many oxygen we have here? 3. Now you can see now. In fact, this one will not even work because you put 5 here. They will be having 5 hydrogen. There is no day, nowhere, no year, no month. You can make the hydrogen balance. Do we get? Just think. So here we have what 2. So it's balanced that way. It's balanced. Now let's check for nickel. Here we have NiOH 3 minus to give us what Ni. So let's add our water here. So here now we can add 4 molecules and 3 molecules of water, 3H2O plus. So now how many hydrogen do we have here? 6. How many oxygen? 6. So this just become plus what? 6OH minus. All the atoms are balanced now. Now let's check the charges. Here we have 2 minus and another 2 minus. That's what? That's 4 minus. Here we have 2 minus. So it has to be balanced. So here for this side we have to add plus 2e minus. And that here will be 4 minus 4 minus. Now let's check this one too. Here we have just minus 1. Here we have 6 minus. How do we make this to be equal? So it's by adding 5e minus here. So this one is now minus 6. When this one is 0, there's no charge. Minus 6 and minus 6 is balance. Now how do we balance everything? Multiply this by coefficient of this one by 5. Multiply this one by 2. So this one times 5. And this second one times what? Times 2. Times 2. So 5 times this, you have 10 OH minus plus 5 times this, 5 SO3 2 minus or minus 2 to give us 5 times this, 5 SO4 2 minus 5 times this, we have 5 H2O. 2 times this, we have, okay, 5 times 2E minus, we are not done. 5 times 2E minus, we have plus 10E minus. So we are done with the first one. Now the second one, 2 times this, we have what? 10E minus. 2 times this, we have what? Plus what? 6H2O. 2 times this, we have plus what? Plus 2Ni OH 3 minus plus 2 times this, we have what? 2Ni plus 2 times this, 2 times 6, we have 12, no, OH minus. Do we get that way? So it's just multiply all this by 2, multiply all this by 2, multiply all this by 5. Like the coefficient of electron in equation 2, use it to multiply equation 1. The coefficient of electron in equation 1, use it to multiply equation 2, you get this. Now this one cancel this 10E minus. Right, so now let's now write everything out. So writing everything out, so here we have the assignment I want to give. Oh, I've cleaned it. Okay, I will paste it on the comment section. I will paste the assignment on the comment section. So here we have 10OH minus plus what? 5SO3 2 minus. Now what's the left side here? Plus what? 6H2O plus what? 2Ni OH 3 minus to give us, what's the right side here? 5SO4 2 minus plus what? 5H2O. The right side here plus what? 2Ni plus what? 12OH minus. Now let's check everything. Now how many hydroxide do we have here? And how many oxygen do we have here? 10. Here we have 5 times 3 15, that's 25. Here 6, that's 31. Here we have 2, that's 33. Now let's check the number of oxygen if it's also equal to 33. 5 times 4 20 plus 5 25 plus 12. 25 plus 12, that's what? Let's confirm it. This is 10 plus 15. 10 plus 15, that's 25 plus 6, that's 31. Okay, sorry, it's not 33. Plus this 10 plus 15, 25 plus 6, that's 31. Here we have 3 times 2, 31 plus 6, that's 37. 37, this 2 times 3, 6 hydrogen, 6 oxygen, right? 6 plus 6 plus 15, that's 12 plus 15, right? And that's 27 plus 10, that's 37. Now let's check the right side. 5 times 4, 20 plus 5, 25 plus 12, that's also 37. So oxygen is balanced. Now let's check hydrogen. 10 hydrogen plus 12, that's 22. 3 hydrogen, that's 25. Let's check here. We have 10 here. Let's check again. 10 plus 12, 22 plus 3. Now let's check this one. Here we have, I'm coming. Oxygen is balanced now. Okay, I'm coming back to hydrogen. Let's check the charges. Here we have 10 minus 5 times 2, that's 10 minus, that's 20. 2 minus, that's 22 charges. We have minus 22. We have 22 E minus. Here we have 5 times 2, 10 minus, and 12. That's also 22, 12 minus. So charges are balanced now. Oxygen are also balanced. Now the hydrogen, we have 10. We have 12, that's 22. Here we have 3, that's 25. Now here we have 10 and 12, that's 24, and that's 22. Three hydrogen is left. What happened? Okay, for now, let's check for sulfur. Sulfur is 5 here, sulfur is also 5. Sulfur is balanced. Nickel is 2, nickel is 2, nickel is also balanced. The hydrogen is missing up somewhere. You have to be careful when doing all these things. You have to be very, very careful. Okay, hydrogen here is even 6. Hydrogen here is even 6. It's not even 3. Here we have 10 plus 12, 22 plus these 2 times 3 is 6. That's 28. 28. Here we have 10 and 12, that's 22. There is 6. There is 6 hydrogen somewhere. 6 hydrogen somewhere. There is 6 hydrogen somewhere. 6 hydrogen somewhere. That's just be careful. I've cleaned the question, I would have done it again. So that's that for that, but I think I've explained it enough. Just yeah, if I see where it's missing, I'm going to put it on the comment section and also put the assignment on the comment section. Thanks for watching. Don't forget to like and subscribe and drop whatever you want to drop on the comment section. I will surely attend to it. Thank you. But please, whenever you are doing something like this, check the number of charges, the number of atoms. If they are not balanced, that means you have made a mistake. So you have to trace your step back. But I think the explanation is very clear now, so you can apply it. And the main part is that you should be very, very, very careful. Thank you.